Hi, we are going to talk about the inverse sine function. First of all, just to remind you, a function is going to have an inverse only if it has a one-to-one relationship. And if you look at the graph of sine, it is not one-to-one. But what we can do is we can restrict its domain and make the resulting function one-to-one. So what we do with the graph of sine, we are only going to select this much. And on this interval from negative pi over 2 to pi over 2, the graph of sine, it has one-to-one relationship. For every x there is only one y, for every y there is only one x. So then what we do, the domain is going to be from negative pi over 2 to pi over 2, and the range of this function is going to be from negative 1 to 1. So then when we do the inverse sine, the domain is going to become negative 1 to 1, and the range is going to be from negative pi over 2 to pi over 2. So what is important to understand when we solve, for example, trigonometric equations, and they all have multiple solutions, you have to remember when you do it with the inverse sine, there's only one solution that you're supposed to get, not more than that. Right? And that solution must fall on the interval from negative pi to pi, as you can see from this picture. Alright, let's take a look. So the idea here to evaluate this without a calculator, inverse sine of square root of 3 over 2. So where is it going to happen? On the interval from negative pi over 2 to pi over 2. You should realize this here is going to be pi over 3. Where is inverse sine going to, what's the inverse sine of negative 1/2? Well, negative 1/2, that's gonna, there is a solution at pi over, well, no, there's a solution going to be at negative pi over 6. Negative square root of 2 over 2 on this interval, it's going to only happen at negative pi over 4. Okay. Some of the problems that you're going to have is where you have an inverse function of a sine of a particular angle, and you want to find out what the value is. So basically what we have here, we take sine of pi over 10, get a value, and then plug this value into the inverse sine and try to figure out what that is. It should be, and remember this answer here, when you do the inverse sine, arc sine, this answer here must be on the interval from negative pi over 2 to pi over 2. But it almost looks like they're going to cancel each other, right? Because if you do sine of an angle and then you reverse that, you are going to get that some angle looks like, right? The answer here is actually going to be pi over 10. Think about this as if you would with the, for example, squaring a number and then taking the square root of that. It's not exactly the same thing. You do need to be careful. You will see what's going to happen. But a sine and its inverse are going to actually kind of cancel each other. Alright, here we do an inverse sine of a sine of negative pi over 5. So what angle is that going to be at? This is going to be at negative pi over 5. Okay. But what is going to happen with some of the angles? Is it always going to be as simple? Because sometimes students look at this and they go like, oh, I got it. So you just, one thing cancels the other and you're just going to have this value here. Or this value here. Not quite. If you look at example 6, you may want to think that the angle is going to be 4 pi over 7, but that's not the case, because 4 pi over 7, if you write 4 pi over 7, it is greater than pi over 2, because it's more than half of pi. And that's not going to work, because our value must fall on the interval from negative pi over 2 to positive pi over 2. So what do we need to do? The easiest trick to this is going to say, well, this answer here, let me show you the graph for a second. 4 pi over 7 is going to be somewhere here. So there's going to be a symmetric value on the other side. Okay? So like for example, if 4 pi over 7 is here, will be another value here that's going to have the same coordinate. And what you can do is you can actually say, okay, it's going to be then pi minus 4 pi over 7, which is going to give you 3 pi over 7. And that is going to be the answer here, 3 pi over 7. Okay. This next problem, you do arc sine of negative 2 pi over 5. So is the answer negative 2 pi over 5? Does this angle fall on the interval from negative pi over 2 to pi over 2? Yes, it does. So the answer here is negative 2 pi over 5. This next one, same problem. 4 pi over 5 is over 4. I'm sorry, negative 4 pi over 5 is actually less than negative pi over 2, so it falls outside our desired interval. What can you do then? Well, if we try to do the same trick as we did earlier, which was pi minus negative 4 pi over 5, that's going to give us an angle that's going to exceed pi over 2 also. But because it's on the negative side, what we're going to do is we're going to do negative pi minus negative 4 pi over 5. And that's going to give us negative pi over 5. So the value is going to be negative pi over 5. Again, let me show you really quick what it's going to look like on the graph. So negative 4 pi over 5 is somewhere here. So we want to be here, the same value, right? You do need to look at the graph of sine, not the inverse sine, to make sure you can understand this better. Okay, so that's why it's meant to be 5. Okay, and that's it.